Atom achieve octet or duplet rule by forming chemical bonding. So we have three types of chemical bonding. The first one, ionic bond. Second one, covalent bond. And the third one, dative bond. Okay, let's take a look one by one. Ionic bond. Sometimes we call it as electrovalent bond. Why? Because ionic bond involving the transferring of electron valence. Okay, valence electron. We transfer the valence electron, transferring from metal to non-metal. Okay, so when it stays like this, meaning that the bond is forming between metal and non-metal. So you can have one atom which is metal, another atom which is non-metal, bond together. Okay. So what happened? Firstly, metal will donate electron to form positive charge ion. We call it as cation. Non-metal will gain or accept electron to form negative ion that we call as anion. Okay, but this is not the definition of ionic bond. What is ionic bond? Ionic bond when the positive charge ion and negative charge ion attracted together, or you can simply say as ionic bond is electrostatic forces between cation and anion that hold them together in solid crystal. So that is the definition of ionic bond. How to show electron transfer? By using Lewis dot symbol. For example, if you want to draw Lewis dot symbol for formation of NaCl. So first one, you need to draw each atom, the Lewis dot symbol. Okay, Na, there you have 1 dot. Cl, there you have 7 dots. Okay, so starting with Na is metal, Cl is non-metal. So Na will transfer the electron to non-metal atom. So how? Just bring an arrow towards the electron that not yet paired with any electron. Okay, so if you see here is already paired, paired and paired. So bring the electron to the electron not yet paired. Okay. Okay, so what is the product? The product, you should draw it like this. So draw the Na with the bracket. So inside the bracket, representing the how many valence electron left. So now Na already lose its electron. So in the bracket is empty. And the charge of Na would be plus charge because it lose 1 electron. What about Cl? Cl gain 1 electron. Okay, so put the bracket of Cl. Okay, so bracket means that the ownership of the electron. Okay, so it has dot, 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 dot. Okay, so original 7 electron. Gain 1 electron. So now Cl has 8 electrons. And gaining 1 electron give Cl negative charge. Okay, so this is the ionic bond. Okay, so this is ionic bond. The bracket should be close together. Okay, closer. Another example of ionic bond is Na2O, where Na is metal, oxygen is non-metal. So Na has only 1 valence electron. Oxygen has 6 valence electrons, so oxygen will need another 2 electrons to complete the octet configuration. So Na will give the electron to oxygen, but one Na can give only 1 electron to oxygen. So we need 2 atoms of Na. So how the ionic bond would form? Na will give the electron to the oxygen, unpair electron on oxygen. Another Na will give the electron to another side of unpair electron on oxygen. And the product would be Na plus ion, since it loses 1 electron. But we have 2 atoms of Na, so we will get 2 ions of Na plus. Okay, so inside the bracket is empty. Oxygen. So put the bracket near to the Na bracket and draw the oxygen inside the bracket. So oxygen, originally it got 6 valence electron and it gained 2 electrons from Na. So it will give you 2 minus charge on oxygen. Okay, so this is the formation of ionic bond or electrovalent bond. So this is the product. Make sure Na and oxygen is close together. So the next one is covalent bond. Covalent bond is a bond where 2 electrons are shared by 2 atoms. And the 2 atoms usually non-metal bonded with another non-metal. But sometimes non-metal also bond with metal, but this is not ionic. It is still covalent. How? When you have this metal Be, Bal. So beryllium, boron, aluminium. So these 3 atoms come from metal, but they can also form covalent. Okay, so the exception. So why is this happening? Covalent bond forming because the differences between electronegativity is small. So when the difference between electronegativity is small, differences between small different, it will form covalent. But if the difference between electronegativity is large, okay, so big difference, it will form ionic bond. Okay, so this is Pauling scale where you can see the electronegativity. So you can just minus. So 2.5 minus 1, the total would be greater or equal to 1.7. The bond would be ionic. But if less than 1.7, it will be covalent. Okay. Example for formation of covalent bond. So let's say you have hydrogen. So hydrogen is non-metal. Hydrogen want to bond with another hydrogen. So one hydrogen contains 1 valence electron. So each of them will bring their valence electron close together. Okay, so when they are close together, they will form a line. So you just represent these 2 electrons as single line. So this single line contains 2 electrons. This is what you call as covalent bond. That's it. Okay, simple. So this is another formation of covalent bond where hydrogen bonded with Cl. Okay, so hydrogen obey duplet, so it will need just 2 electrons. So it already have 1, so it will need another 1. Cl obey octet, so it already have 7, so it will need another 1. So hydrogen and Cl bring their unpaired electron close together. So you just replace them with a single line. And this single line contains 2 electrons, and this single line also you call as covalent bond. Okay. So Covalent bond, you can have single bond, double bond, or triple bond. Okay, so this is example if you want to form double bond. So oxygen, O2, oxygen gas. Each oxygen contains 6 valence electron. So 6 valence electron, if they want to obey octet rule, they will need another 2 electron. So the 2 electron is shared. So one pair, one pair. So 2 pairs of electron is shared. So you can simply replace the 2 pair of electron by 2 single line. So this is what you call as double bond. So 2 bond, you contain 4 electrons. So this is double bond. If you have triple bond, let's say N2, that will contain 6 electron shared. So comparison between these two types of bonding, covalent and ionic bond. Covalent bond involving sharing of electron, but ionic bond involving attraction between cation and anion. Okay. Covalent bond when 2 atoms combine together. Ionic bond, metal and non-metal are held together, but they are not combined. Dative bond, also called as coordinate covalent bond. Actually, dative bond is a type of covalent bond as well. Okay, so they are covalent bond. So involving sharing of electron. But the sharing in covalent bond, in normal covalent bond, if A want to bond with B, meaning that A give 1 electron, B give 1 electron, and they share the electron. So this is covalent bond. But in dative, A will not bring any electron. A is just A. B will have both electron. Okay, so the pair of electron coming from only one atom, so B share the electron to A. So this is what you call as dative bond. They are sharing, but only one give the electron. Only one atom share the electron, the other just waiting for it. Okay, so we represent dative bond using arrow. So the arrow is the bond. This arrow is 2 electron. Okay, so this arrow is bond actually, not normal arrow. Okay, so this is example of molecule that has dative bond. So let's take a look how it formed. Hydrogen, H plus originally. H don't have any electron because it's plus charge, meaning that it already lose the one and only electron. Okay, so H plus don't have any electron. Ammonia, NH3, has a pair of electron as lone pair. So what happened? This lone pair or this pair of electron is shared with H plus. And the sharing we represent as arrow. So this contains 2 electrons. Okay, so the arrow pointing from donor to the acceptor, meaning that arrow showing that the nitrogen is sharing the electron with hydrogen. Nitrogen, the only one, give the shareholder. Okay, so even though the bond I put it like longer than the other bond, the other single bond, this arrow look like it's longer than the other bond, but in actual molecule, no difference between normal covalent bond and covalent dative bond. The bond length and bond strength is exactly the same. Okay, you cannot differentiate between dative and covalent.